So the first one is Poisson process. Its property is the number n of the points ti in the interval t1, t2 of the length t2 minus t1 is a Poisson random variable with parameter t. So the second is if the interval t1, t2, and t3, t4 are non-overlapping, then the random variables n and n are independent, and at a time moment t, there is no more than one Poisson point. Using the points ti, we form the Stammacher process xt here. So the first order probability mass and the means and auto correlation and the auto correlation is here. So the second is Poisson increment. So he defined as this, and xt is Poisson process. So his first order probability mass is here. So mean and r t1 t2, c t1 t2 is here. So we know that it's a triangle with area lambda, which is independent of where goes 0. The triangle becomes a impulse with area lambda. So the second one is Poisson impulse process. He defined as zt, and xt is also Poisson process. Its mean is this one, and the auto relationship is r t1 t2. Auto covariance is here. So the process zt equals lambda has 0 means and the autocorrelation. T1, T2 equals lambda. So the fourth one is simul random telegraph signal. He is defined on based on Poisson points again. The number n of the points t1 in the interval t1, t2 of length is a Poisson random variable with parameter here. So we can find his mean is here, and his autocorrelation is here, and his auto correlation is here. So p xt equals 1 is not 0.2 because we start with -1. So we see that the fifth is called the random telegraph signal, and he is defined with this, and xt is a simul random telegraph signal, where we can see his first order probability mass is here. So his mean equals 0, r t1 t2 equals this one, and c t1 t2 equals this. So last one is called random walk. You can toss a fire coin n times, and the case the number of hands in n toss, so we get this one. His mean equals 0, and his r t1 t2 equals this one, and his c t1 t2 equals this. So the seventh one is called Williams process, and we can define as this one, where xt is the random walk. So the mean equals 0, r t1 t2 equals the minima of t1 t2 multiple lambda, and the c t1 t2 equals minima t1 t2 multiply lambda.